All right, so here are a few situations where the sum and difference identities are useful. So here we're being asked to find the exact value of each expression, right? So if it didn't say exact value and it just said round, and remember, exact value is actually the default is the expected way to express your answers unless stated otherwise. But if it did say find the value of each trig function round to the nearest tenth or something like that, then we could use our calculator and we could just plug in cosine 75, right? Now, we've done exact values before without the calculator, but we need the unit circle to do that, right? And cosine 75, we don't have a 75 degree value on the unit circle, right? We go from 60 degrees to 90 degrees because what we can use with the unit circle is just our special triangles, right? So 45, 45, 90, 30, 60, 90. So all the angles around there are come from one of those types of triangles, and 75 does not. So if we want to do this exactly, then we have to find a way to use what we do know on the unit circle to be able to in a composite way, figure out cosine 75. Okay, so let's take a look at our sum and difference formulas. So here we go. All right, so the sum and difference formula says for cosine, right, this one here, cosine of a plus alpha plus beta equals cosine alpha plus, or cosine alpha times cosine beta minus plus sine alpha sine beta. So 75, what I want to do is I want to try to think of this as a sum or difference of two angles, okay? So there's a few ways to do it. So remember that the angles on our unit circle, and here's our unit circle, the angles on our unit circle are, and let me just think of some that kind of are around 75. So I have 45, 60, right, 30. And so what combination of those angles can I use to get 75, right? And remember, by adding or subtracting, and there's a few ways to do it. One way is 30 plus 45, right? So I can do 30 degrees plus 45 degrees, okay? And that's the same thing as 70, right? And that's what we're going to use in this example. But you could also, just to let you know, you could also do, let's see, 120 minus 45, right? That would be another way to go. 120 minus 45. And there's usually, there's actually an infinite amount of ways to do these. But in terms of your unit circle and the values there, there's usually a few good options. So, and usually like a one sum and one difference that are pretty good options. Okay, so this one we'll use the sum, and then I'll show you a cosine one with the difference later on. Okay. All right. So I have cosine of 30 plus 45, and so what I'm going to do is I'm going to use this formula here, right? So I'm going to use this formula, and so I know it's going to be cosine of alpha, which in this case alpha is 45, right? So I'm going to put 45 here, and I'm going to put 45 in this other spot for alpha. Let me just move this a little bit. So I'm going to put 45 here, right? And then I'm going to put 30. I'm going to put 30 here, and I'm going to put 30 here, right? All right, so I'm going to erase these just so I can use them for next time, but that's where everything's going to go. So this is going to be cosine of 30, cosine of 45, and then remember, since it's a plus here, it's going to be a minus here, right? So since it's the top one here, it's going to be the top one here, and so it's going to be that minus. All right, so it's going to be minus sine 30 sine 45. All right, so that's how we set it up. Now we plug in the values for each of these, the exact value. So cosine of 30, remember cosine is x. So here at 30, cosine is root 2 over 2. or excuse me, root 3 over 2, sorry. And cosine of 45 is root 2 over 2. Okay, and then sine of 30 is 1/2. And sine of 45 is root 2 over 2. All right. And so now we'll multiply. So root 3, let me just zoom in just a little bit so I have a little more space. So root 3 over 2 times root 2 over 2 is going to be root 6 over 4. Okay, so top times top, bottom times bottom. Can't reduce that. It's tempting to want to reduce, but the radical cannot mix with the number outside the whole number down there. All right, then for this one, 1 times root 2 on top is going to be root 2. 2 times 2 on the bottom is 4. So it's root 6 minus root 2 over 4. And we have a common denominator already, so we'll just combine these. Remember, these are not like radical terms. They don't have the same radicand. So we're just going to leave it like that. All right, and that's how a lot of these answers will look. You'll have a similar look to a lot of these double angle, or excuse me, sum and difference angle problems. All right, so that's the exact value of this. Now, one way to double check your work is you can plug this in your calculator, and then you can plug this in your calculator and see if you come out with the same decimal. Okay, so that's a way to check your work. Make sure you're in degree mode, right, as usual. All right, let's check out number 2. So number 2, I have sine of 165. Let me zoom back out here. Okay, so I have sine of 165, or negative 165. So I want to think of what are 2 angles I can add together or subtract to get negative 165. And once again, there's multiple ways to do this. So let's see. I'm going to go sine. And I'm thinking since it's negative, I'll do a difference. So it's going to be, I'm going to be subtracting 2 things. So let's see. So what if I did, let's see, subtract, see if we can subtract from 180. So if I did 45 minus 180, that wouldn't work. What about 210 or 45 minus 210? Right, that should work. So 45 minus 210 is 165, so those are equal. And so I'll just state it this way. That way I can use our sum formula, right? In this case, actually our difference formula. So I'm going to say sine of alpha, so that's 45. Okay, so I'm putting 45 in here for alpha. And then I'll put 210 in for beta. Right, and since we're subtracting here, we're going to have a minus here, right? So it'll be sine of 45 cosine 210 minus cosine 45 sine 210. All right, and then we're going to put in our values based on the unit circle. So in the unit circle, sine of 45 is root 2 over 2. And cosine of 210, so here's 210, cosine is negative root 3 over 2. Okay, and then we have cosine of 45 here. So cosine of 45 is root 2 over 2. And sine of 210 is negative 1/2. All right, and so now we can multiply. So root 2 over 2 times negative root 3 over 2 is negative root 6 over 4. And then negative root 2 over 2 multiplied by negative 1/2, it's going to be positive root 2 over 4. Okay, so what we end up with is negative root 6 plus root 2 over 4. Or you can flip it around and say root 2 minus root 6 over 4. Okay. So once again, a lot of similarities, right? Same 2 values on top, different signs. It's the opposite actually of what we got in the last problem. So anyway, that's how we use sum and difference formulas for angles, okay? So I'll show you one more of each. So since we used the difference formula here, we'll use the sum formula with this sign. And since we use the sum formula here with cosine, we'll use the difference formula here, okay? All right. Now, there's other ways to do what we just did, right? We could have done negative 120 plus negative 45, right? And that would work for us. Or negative 135 plus negative 30. So that would have been another way to do it. And then there was, other ways that we could subtract as well to get that. All right. So number 3, sine of 195. So since I used the difference formula for this sine, I'm going to use the sum for this one. So even though I could do, let's see, I could do 225 minus 30, right? I could do a difference formula here. I'm going to do a sum formula. So I'm going to do sine of 195. So let's see, I could do 150 and 45, right? Could do 135 and 60. I could do 120 and 75 wouldn't be ideal because that's not our unit circle. So let's do what we just said, 135 and 60 degrees. Okay. All right. So we're using the same formula here. And we have a sum this time. So it's going to be, we're going to put 135 here. So that means 135 here and 135 here. And then we'll do 60 here. Okay. And so we'll have sine 135 cosine 60 plus this time, right? Whatever this is will be the same for the sine formula. And then we'll have cosine 135 sine 60. All right. And so sine of 135, we'll put that in, put in the cosine of 135 sine of 60. So sine of 135 is root 2 over 2. Right? Remember, it's equal to y. Cosine of 60 is equal to 1/2. Right? Should be looking pretty familiar. Cosine of 135 is negative root 2 over 2. And sine of 60 is positive root 3 over 2. All right, so what we end up getting is root 2 times 1/2. Root 2 over 2 times 1/2 is root 2 over 4. And negative root 2, change that to a minus. Negative root 2 times root 3 over 2 is going to be negative root 6 over 4. And so we end up with actually the same thing we had on this last one here, right? So we end up with root 2 minus root 6 all over 4. All right, and then the last one we'll do together here is cosine of negative 105. So since we did a sum of cosine before, we'll do a difference here. So negative 105. So I want a smaller angle minus a bigger angle, right? So I could use, let's see. Yeah, we could do 150 or 45 minus 150, right? Or we could do 30 minus 135. So yeah, either way, or then there's some other options too. But let's do 30 minus 135. That'll equal 105, right? All right, and remember cosine, so we're using this one now. So if I put in 30 here, I want to put in 30 here and here, and then 135 here, and also here and here. But remember that when we do a minus, then we're going to have actually a plus right here, right? So it's going to be cosine 30 cosine 135 plus sine 30 sine 135. All right, then we'll just plug in those values. So cosine 30, so that's going to be root 3 over 2. Cosine 135 is going to be negative root 2 over 2. All right, so then we have sine 30, which is 1/2, and sine 135, which is root 2 over 2. So it ends up being negative root 6 over 4 plus root 2 over 2 after we multiply. And so it'll actually be, the same thing we got in the last couple, right? So it'll end up being root 2 minus root 6 over 4, right? So I put the negative one second, so 2 minus root 6. And that's it. All right, so try out number 5 and try out number 6, okay?